Hello and welcome to another LeetCode video. Today we're going to be doing problem number 102, binary tree level order traversal. And the reason I wanted to do this problem is because in most of my videos for binary trees I use a recursive DFS for pretty much every problem. So I wanted to show how you could do a binary tree traversal using a BFS, which is going to be good for the level order traversals. So let's read the problem. We have a tree, so let's actually draw it out. And we want to turn the level order traversal of its nodes. And so what they mean by that is you want to return the traversal of the nodes level by level. And by level, I mean the nodes that are on the same line like this. So let's see what that would look like. And then each level is going to be its own array. So for the first one, we would go to this level, for this. For the second level, this would be 920. And we want to do it left to right, I believe. Yeah, left to right. So. And now the third level, we have this. So it's 15, 7. And so they're showing with a root of only one level, we just return 1. And then with an empty root, we return nothing. So how do we do this? How do we do a level order traversal of a binary tree? It's going to be relatively straightforward. I'm actually going to go back to this part. And what we're going to use is we're going to use a queue. And we are going to pass in the root. And then we're going to go level by level in the queue and pop the nodes in the queue and push new nodes to the queue. So let me show you how that's going to work. So let's call this queue. We're going to put in the root first. So we'll put in this root node, cross that out. Now we are going to have our result. Let's call that R. And so what we're going to do is we're actually going to, level by level, we're going to figure out how many nodes do we need to process before we get to the next level. And then we're going to append one to the level, and then we are going to keep going. So in the beginning, our level is level 0. And the nodes we have left to process, let's call that n, is one node because that's the length of the queue. Okay, so we're going to pop this node. We are going to add its value into the levels array. And actually what's going to look like there is we're actually going to have like an array here that we're going to add values of nodes on the current level to. And then once we're done with the level, we're going to push that into the result. So we're going to push 3 here. Now we're going to push the children of 3 into the queue. Which is going to be 9 and 20. Push those into the queue. And then we are done with that level because we only had one node to process. It was the length of the queue. So now we're at level 1. Our nodes to process is 2. And we push this array up here. And so that's going to look like 3. And then we have a new array again. So now we're at level 1. We need to process 2 nodes. That's the length of the queue now. So we're going to process node 9. Okay, we're going to process it. We are going to put its value into our array. We're going to put its children into the queue. It has no children. Okay, now we're going to go process node 20. And so we're going to put its value into the array. And then we're going to put its children into the queue. So we have 15 and 7. Okay, these are our 2 nodes. And then we are going to, we're done with the level. We process the 2 nodes. Now our new number of nodes processed is 2 again. Now we are on level 2. And so we push this array up here. And that's going to be 9 and 20. Okay. So now we are at this 15 and 7. So we have a new array again, right? Every level we have a new array. And then we're going to push that array up to the result. And we're going to make a new array again. So we are going to process 15. It has no children. So we're going to put the value 15 here. And we are going to process 7. It has no children. Okay, now we have no more nodes in the queue, so we're done. So our level's done. This is done. We're going to push this up here again. And so this is going to be 15, 7. And so those are our steps. I'm going to write them down right here. Let's make it a little bigger. Font 30. So put root into queue. Process queue level by level. Count how many nodes there are on the level. Process each node. And by process each node, I mean put nodes value into new array and its children into the queue. then I'm going to write the last steps over here, maybe. So let's see here. Yeah. So we count how many nodes there are in the level, put the node's value into the new array, and then it showed it onto the queue. For when done with level increment, we don't even need to really increment the level. We push our level array into result, create new array, and figure out nodes in next level. Okay, so that's pretty much it. So we are going to put in the root, we're going to process the queue level by level, count how many nodes there are on that level. We only need to process that amount. We need to put the values into the new array and it's shown into the queue. And then when we're done with the level, push our level array into the result, create a new array, figure out nodes in the next level. And the final step, I'm not going to write it down, is we just do this until our queue is empty, and then we return the result. So let's code that up. And this is going to be different from a depth first search. I can talk about a depth first search quickly. So with a depth first search, what you would do is you can do the same thing, except you would have a recursive function, and it would take in the, I think I've done it in some other problems recently, where you have a recursive function that takes in a node and a level, and then you just say, like, if this level hasn't been visited before, then in my result array, make enough arrays so I can actually push into that level. So like, for example, if in your result array, you're here, and you have some value like 1, but now you're at level 2, you know, let's say index like level 2, and this is index 0, then you would have to push arrays into your result until you can actually put something into here. And then you would just put the node's value in, and then you want to go root left right in your traversal. So you want to go root left right to ensure that we put in the left nodes first. And so the way that would work for like this, for example, is you would process the root, then we would want to go left, then we would want to go right, then we want to go left, and then we want to go right, and the nodes get processed in the right way. So that's how you do it with the DFS, but today we're going to focus on the BFS because I haven't done that yet. So first thing first, we're going to make a queue. So we can just call that maybe cur level or something equals queue. We are going to pass in the root here. And the other thing is we're going to do is we're going to check here because we're not going to handle for null nodes. We're going to check for here if the root is null. So if not root, you can just return straight away. So we're going to pass in the root into the current, so this should actually be not a queue, but a deck. Okay, so collections.deck. Okay, now what we're going to do is we are going to have a result as well, right? Okay, and that's all we need now. So now we just need to run our algorithm. So while the current level is true, while we have levels to process, first thing we do is we're going to have so actually I don't want to call this current level. I'll just call this nodes. Yeah, this is going to be nodes. So while we have nodes, yeah, perfect. So our current level is actually going to be here. It's going to be a new array. And then we are going to do a for range loop to figure out how many nodes are in the current level. So that's going to look like this. For this in range length of nodes. And the reason we use this underscore is because we're not going to use this value. We just need to make sure this iterates the amount of times that there are nodes in the queue. And so if there are like nodes like this, like 1, 2, this will iterate 2 times, even if as we're iterating through it, we're putting in more nodes. This is like a snapshot of how many nodes are there now, and that's how many times we're going to iterate, regardless of how many more nodes we are putting back in. Okay, so that's going to be that. We need to pop the node, so we can just say node equals, we can say this is nodes dot pop left. We're going to pop from the left of the queue. Okay, now we need to add the value into the current level array, right? So cur level dot append. So this is this. This is going to be node dot val. Now we need to take the children of the node, right? Like let's say we need to take the children of the node. We need to put them into the queue so we could process those later. So that's going to be if node dot left, and we're going to put those into the queue. So nodes dot append node dot left, if node dot right, nodes dot append node dot right. Okay, now at the end of the loop, we are going to we need to take the current level, we need to push it up to the result, right? So res.append current level. Okay, and then finally at the end we need to return the result. And let me just double check here. So if not the root, we return nothing. We make a queue, make a result, perfect. Current level equals nodes.pop left. Current level append node.val, nodes.append. Yeah, I think we should be good to go here. Just see, screwed up anywhere? Okay. Okay, perfect. So let's go over the time and space complexity here. And yeah, this is another good thing to know. Like, I think you are going to want to know how to do a depth first search and a breadth first search of trees for interviews, because you might get asked to do one or the other, or, you know, your interviewer might prefer one or the other and might tell, like, if you know how to do one, they might be like, well, do you know how to do it any other way, and so on. And so just like knowing both for the versatility, and both are useful for, you know, for doing these level traversals or for other things. So the more stuff you know, the easier it's going to be for you to do problems, because you're not going to have to do it all in a one specific way. Okay, so for the time here, so what are we doing? We are processing the nodes level by level, which means we're going to process every single node. So that's going to be O of n, where n is the number of nodes. And yeah, so a pop should be big O of 1, and append should be big O of 1 because we're using a queue. So those should be, so that should just be big O of n to get the level order traversal there. Now the space, so we are using a queue. And then worst case scenario, how many nodes can we have on a level? Well, it's actually, I think, going to be big O of n, technically. Yeah, because, like, let's say we had a queue, if you think about it. Let's say we had a full binary tree, right? So it would be like this, then like this, and so on. And so once we actually get to this bottom level, the number of nodes in this bottom level is pretty much n over 2. It's not exactly, but it's roughly. And so if this is O of n over 2, space complexity, then we would get rid of this, and that would be big O of n. So the bottom level worst case scenario is going to be really big, and that's going to be half the binary tree, which means we have O of n complexity. If we use a queue, yeah, so we have this nodes. Then as far as our result, I don't think we need to count, like, the result. It shouldn't really count in space complexity because that's what we need to be returning. And then as far as anything other than that, I don't think we're storing anything else. So yeah, I think that's it. Okay, so that's all for this problem. Hopefully you liked it. It's definitely a good one to be able to know, a good one to be able to do in multiple ways. And if you did like it, please like the video, subscribe to the channel, and I will see you in the next video. Thanks for watching.